just by going through the effort of writing the specification, of formally defining the program in another language, how many times did you catch the bug? Did you know there was a bug? For sure, before even running the engine. And people were like, oh, 95% of the time. It's more of the effort of going through the effort of formally thinking about something rather than the actual proving part.
Scraping Bits is brought to you by the following sponsors. MEV Protocol. Maximize your ETH staking value with MEV ETH, exclusively on MEV.io. And Composable. Execute any intent on any chain, coming soon to Mantis.app. That's MANTIS.APP. And Fastlane Labs, the only MEV and intent-centric team that has a daily deodorant application rate of over 68%. GM everyone, my name is DeGatchi, the host of Scraping Bits, and today I'm with a special guest that just came from ETH Paris, Goncalo.
Hi everybody, thank you for having me.
Thank you for coming on. Just for some context, for people that don't know you, who are you and what do you do?
Yeah, I am a co-founder in the ConsenSys Diligence team, also an auditor. I've been auditing for almost 7 years now, and also a technical partner at Ethereal Ventures, the VC fund.
You've had quite an interesting kind of career path so far. You were in Web 2 auditing, and then you kind of transitioned into Web 3. So what was life before Web 3?
Yeah, life before Web 3 was a little bit less weird in some ways. I was already hacking stuff before, never professionally though. So all my startups were in fields that had nothing to do with security. I was building stuff before. I had stints in ad tech, which is an awful industry, by the way. Stints in biotech hardware, in mobile apps. But on the side, I was super interested in security since I can remember, since the first time I touched the computer. And so in 2016, after knowing about Bitcoin, I knew that Ethereum was coming out, and we started mining, me and two other friends. Unfortunately, ended up losing a bunch of value when the DAO got hacked, because I sold dollar tokens for 33 cents on the dollar, and not believing that the hard fork would happen. And that's what triggered my leap into Web3 full time. And since then, so I know that you had John Marlin on the podcast in early 2017, found my way into ConsenSys, and John, Joseph, and I actually kickstarted the security team that is now ConsenSys Diligence. It was very organic, though. We just started doing audits. People started paying for them. And so we started having external clients very surprisingly at the time. And it just turned into a full-blown team, or back then, its own corporation, actually, in Zug, Switzerland. And then it spun into ConsenSys Software.
You're still with ConsenSys Diligence right now, or you kind of moved on?
Yes, right now, I'm trying to take myself a little bit out of the day-to-day tasks. And Liz Daldalian has been running the day-to-day operations of the team, since I'm trying to focus a little bit more on a new venture that I'm guessing we can talk a little bit about during the episode called Creep. But yeah, we can go into that later.
Yeah, for sure. But since it's a new venture, I think it's good to touch on this topic of just the startups and what your process was through them and the difficulties you faced, building these as well. Just in general, right? Because startups, it doesn't matter really the industry, you all go through the same kind of struggles, right?
Absolutely. No, and I think that, so this is probably 15, 16 years ago. And my first try was on the biotech hardware space. So I was trying to do a blood pressure estimator. So it's not a way, it doesn't measure the blood pressure directly, but instead it was using ECG and oxygen levels to estimate the blood pressure. And so we were trying to get it to a point where it would be it could be FDA approved according to the error margins. What I realized is that there was little to no money for software companies back then in Portugal, where I was based, let alone for hardware. So I think that was my first shock, my first contact with how to deal with lack of funding. What ended up happening is that it went nowhere. So we actually had an algorithm that worked. We never even got a prototype off the ground. So that was the first struggle. People, the fact that you don't know how to market yourself and your company just means that people won't even look at your stuff, even if it's good. So that was one of the struggles. Then the next couple of startups, one of them got $300K seed funding. it actually went nowhere. So I think it still exists, but it went nowhere. And the mobile app, it was a super crowded market at the space, so it ended up like not doing that well. We had some ad revenue, but nothing much. And at the very end of the day, I think they all failed because of money. I think that was always my problem.
Why? So like a scaling problem or marketing?
Yeah. So I think that like the VC landscape or startup scene, if you will, in Portugal back then was like a little bit pernicious, like it was like a closed off group. There was like a handful of people that had contacts with banks. And the biggest VC back then was Caixa Capital, which is like one of the governmental bank in Portugal. And so like it was hard to pierce through. And during the last one, the EdTech one, even the seed funding, like we had to battle our angels because like they're like, no, we promised you like 100K in services, which is like after the fact, after the term sheet was signed and so on and so forth. So people are hard sometimes, and you got to choose that was a lesson, to be honest. Like you got to choose your angels wise. Like don't do a pre-seed round with shitty people.
When do you actually need to get VC funding? Because let's say you are building a project that doesn't actually require any money to run. It's like, for example, a standalone tool like what I'm building with Nibble and Bytes. It doesn't actually need money. I guess the only reason you would need money is to, hire people or for marketing. But at that point, when do you realize you need that kind of assistance?
Yeah, I think in that case, the industry does matter. So, for example, like for us in the edtech space, there were a lot of upfront costs. So we needed to connect to DSPs, right? The data providers. So we needed to get the ads from marketplaces like Adobe or like Facebook and shit like that. And so those upfront costs, they're like really high, like highly priced licenses. And we actually needed money to just operate, right? If you have a tool that you can sell to people with little to no upfront costs, or maybe you just have the maintenance, like the infra maintenance, like if you even have it. But if you can, I wouldn't raise money at all, because like at the end of the day, like you might get shitty agents, and VCs are worse than bosses, so if you can, and I do think security lends itself well to these kinds of businesses. And even like if you're doing like a services business, right? Like an audit shop or something like that, like why not bootstrap? Like if you get clients from day zero, then why should you be putting yourself under strain and like having to worry about giving like high returns or like 4 or 5x multipliers, maybe 10x to your investors if you don't really need it? Just like take a little bit longer to scale the team, right? You don't need it on day one.
Yeah. You no project fails from scaling slowly.
Yeah, I don't think so either. No.
As long as you have an MVP, you can finally start iterating on that, right? But I think that's the hardest thing of any startup, is getting to the MVP stage. In your experience, free startups and now, doing this venture thing, what is the easiest way or the most streamlined way of getting to the MVP state, of like going through it, failing?
Yeah. But as I said, like I think the first one didn't even get to like a POC stage. It was like so early, we didn't even get to try anything. The ones that followed, we actually got some sort of product market fit. It wasn't enough, and also like we were young, money was lacking a little bit, and I don't think I've ever got any lessons from the first 3 ones about like reaching an MVP stage. It was all about money, like I said. Like with Dilligence and lately with other things that I tried, I think that, and this is nothing more than a belief. This is not structured. This is based on anecdotal evidence. I think that if you have MVP, like if you have product market fit, that is apparent. That is extremely apparent. Like it is apparent to you that you're at least gonna get there. I feel like, because with Dilligence, again, like it was supernatural, right? Like there was a clear need in the space. And so we didn't really know what shape it was going to take, but we just started doing work. Like people just started paying us. And like, it was clear that even if our first iterations of what the team was looking like wasn't really there, that it was going to succeed, that it was going to go somewhere. We took a bet we can go into it, and I know that you like automated analysis stuff, and we made a bet early on about betting on tools, right? Security tooling. And this is much of John's work, to be honest, because he found Bernard Mueller early on, back in the early days of Ethereum, where he was building his own symbolic execution engine called Mistral. And he reached out and he started talking about it. And so we decided that Diligence's path was going to be a mixture of services and product offerings on the automated analysis space. And again, we could touch more on it. I'm not even sure that this was a profitable decision, but it might have been because there was a lot of extraneous consequences to that, right? It was not only about the money driven by the product into our treasury, but more about the reputational gains that we had from that. So overall, I think it was a really good bet. The product itself was never wildly successful. And I think it has to do with the number of the developer base in Web3 in general. But bringing it back to the question, so with Dilligence, it was obvious that we had a successful MVP. It just happened. I don't even know, I don't think I took any lessons because it was just like, oh shit, this works. It's very apparent to me that this is going to work. And then another thing that I tried to do 3 years ago, I think, or we launched it 2 years ago, but it has been ideated a year prior to that, was that I'm literally just trying to solve organizational problems that I saw with Dilligence. So that's what I was worried with the most, right? Operational efficiency, if you will, at Dilligence. So just solving our own problems. And one thing that we tried was called Turn, TURN. And it was basically a project to create NFTs for time, basically. So we were selling just digitize our own time and selling it in an auction. Because people were complaining that auditors had a 9-month waiting line and that prices were extremely high. And so I saw this as an opportunity to say, hey, okay, we don't want to mistreat our clients, we're not in the business of just extracting the biggest amount of money. We want to do good work. We want to work with important protocols for the ecosystem. And we want to charge reasonable prices. Obviously, we need to move with the market. If there's a bull run, if there's an insane amount of craziness going around, we should adjust our rates and charge a little bit more so that the waiting time for our clients actually decreases a little bit because it serves as a selection mechanism. And I'm not a true capitalist, so I know that this isn't the best way. And so what we tried to do, and what I tried to put out, was we would digitize our time and then sell it in an auction. This would do a bunch of things, which is hopefully the price by that time, since it's an auction that runs for a while, it's fairer to everybody. And we wouldn't have the organizational burden of having to reschedule people if they're not ready. And I knew that this was true because it's insane to ask that development teams that are on a tight schedule and that don't have that much money in treasury to try and predict when they're going to be ready within a 9 months time window, right? It's insane. I get it. It doesn't work for us. It doesn't work for them. And what was happening was that people would come to us and say, hey, we're not ready, or we're ready before our time slot. Can you do something about it? And so we went back and forth trying to talk to clients, trying to mix and match and reorder slots so that they work for everybody. And the fact that our time slots, and we were selling weeks, basically auditor weeks worth of time, the fact that our time was digitized and was an NFT meant that people could exchange between them. And we would let the market actually self-organize so that they wouldn't need to come through us, right? Do you think this is a good idea? This sounds like a good idea, right?
Yeah, I feel like it's definitely a good way of making money through your time. But then I think you price out a lot of protocols potentially, which is fine if your whole goal of an auditing firm is to make money. Yeah, and then I guess maybe if the demand isn't as high, right, then your price is going to be a lot lower than what you might have like a baseline over it.
Also, this served another purpose, which is like our prices would be public on chain. So there wouldn't, like, I wouldn't take any more of that bullshit saying that we practice, like, like we all collude and charge like unreasonably high prices and that stuff. So, like, this was a way for us to maybe set an industry wide rate, if you will. This is definitely not going to be the case. I knew it, but like, it was an attempt.
I mean, like, okay, so you did that with like the manual one, right? But now you've also released Dilligence Fuzzing, which has a set price subscription. You can do $250 or $2,000 for the pro builder. So why don't you do the same with that? How did you get these prices for, the fuzzer?
Yeah, that's a good question. Let me just trace back a little bit. We'll get there in a second, but let me just tell you, we're asking about MVPs. And so we tried this, right? Like, and it sounds like a good idea. Generally speaking, I thought this was a good idea. And the market rejected it completely. And so, having known what I knew with Dilligence, that it was just happened, it was just like the market needed what Dilligence had to offer. I also realized with Turn that, like, just solving my own problems in what is seemingly non-nefarious in any way is not necessarily what the market is going to take. And we saw a lot of pushback from other security companies, not only because of the transparent pricing thing, but also like even just like the fact that like it had an easy recover, but that it was non-exploitable, by the way. But it was just like an immense amount of pushback for the product specifically. And we realized that clients do not care that fucking much about any of this. This is like all talks that we have amongst security people. And so nobody else cares about it. And so it didn't go anywhere.
It's just like an extra step to actually pay in the service.
Yeah, so I'm probably not the best one to offer advice about like what is a good MVP. Basically, that's what I was gonna get to. But yeah, on the fuzzing thing.
This is quite new as well, this fuzzing tool.
Yeah. So what happened was like we had Methex, which is a suite of tools, right? We had Orchestrate. It still works, by the way, but we're sunsetting it. So we had Methex, which is a static analyzer called Maru, which is closed source. Then we had the dynamic analysis through Mithril, which is open source. The thing about Mithril is also a fun story. Like the symbolic execution engine called it Mithril, and the platform, the orchestration platform that we productize as a SaaS, was also going to be called Mithril, but we got a cease and desist letter from the J.R.R. Tolkien family office saying that we were in breach of Lord of the Rings nomenclature.
Interesting.
So it started being called Methex, and basically static analyzer, symbolic execution engine, and a fuzzer, all orchestrated behind the wall. What we saw is that these tools, in an automated manner, catch code bugs, right? Stuff that happens with the code. You have no way to talk about business logic because it depends from application to application. And so it didn't sell that much. I still think that the developer base is too small. So for a SaaS product that needs volume, it was never really going to go anywhere. There was too little people and dev teams that had money to spend on security tooling. I think that's actually changing now. People are way more security conscious than they were, like, say, 5 years ago. But it was honestly laughable. What we did after a while was like, okay, we need to come up with a way for people to specify what their code does so that the tools can check it, right? And that's how Scribble, that was Scribble's inception. And Scribble is like a partial specification language. It is a specification language, which is like a solidity transpilation. So you use net spec comments on top of functions and contract, and write contracting variants that way. And then we transpile it into pure vanilla solidity from there. And it's free, it's open source, everybody can use it. I think it's a really, really fucking great tool. And I see not a lot of people using it, probably just because like the thing with formal verification is not only about the tools being easy to use or being free, is that it's a different mindset. And developers are not usually there to begin with. And what we did is, so we built Scribble and we were like, okay, the fuzzer, so Scribble works with Methex, but in all fairness, the most powerful tool of the three is the fuzzer called Harvey. Harvey is also closed source, and it's extremely optimized. So I think the ETFuzz team actually used our benchmark, the benchmark that Valentin Wusholtz, which is the creator of Harvey, in our team created. And I think Kitty Fuzz might be right on par with Harvey, but Harvey is an extremely optimized fuzzer, right, for EVM bytecode. And we thought, okay, like we just need to isolate the fuzzer. There's no reason for people to keep paying for the other tools. And we need to give people the opportunity to like just create a better harness for people to use, like, say, Foundry tests with the fuzzer, or just more easily use Scribble with the fuzzer. And we, instead of selling analysis, because the time for the analysis capped within the MythX platform, we'll just like sell CPU time and let people, they don't need to worry about setting up the fuzzer. We have like optimized infrastructure for them to do that. And we'll just tell them like fuzzing time. And that's how Dilligence fuzzing came to be. And so we just put it in general availability 2 days ago, I think. And that's why it came to be. Yeah.
So it's using Harvey under the hood, right? Yeah, which is super interesting because, I don't understand why, auditing teams open source their tools. If it's so good, why don't they just, what I'm saying? Like, if it's so good, why don't you just monetize it? So, yeah, it doesn't really make sense in my mind why someone would open source, something that's meant to be, quite good. Why did you guys open source Mithril and not Harvey, for example?
Yeah, so Mithril was already open source when we acquired it. So Bernard, and one of Bernard's conditions was to keep it open source. So Dilligence acquired the IP from Bernard. Bernard came onto the team, and Bernard was also like, he was doing audits in Web 2 before, prior to that. Like, he had 10 years of experience under his belt. He had won 2 Pony Awards, or 1 Pony Award, DEF CON presentations and all that. And he, like, we wanted him in the team. We wanted the tool within the Dilligence portfolio. And so we just agreed to everything. And that wasn't like a conscious decision, if you will. For the rest, then we got the fuzzer. We bought the fuzzer. Again, same thing. So acqui-hire, we got the fuzzer and Valentin into the team back then. And the fuzzer was closed source, and Valentin had no intention of making it open source. Because, again, this is like the conclusion of his PhD thesis. It was very novel work, not only for EVM fuzzers, but for fuzzers in general. And so he wanted to keep it closed source. Now, if I were to think about that again, I honestly don't know. And like, I'm guessing that there's only one real competition to Harvey right now, which is Echidna, which again is like a different type of product, because like it isn't really optimized for EVM, right? So it's never going to be Harvey, but it's way more powerful in other languages, right? They have ways to make it fuzz other languages. And so it's a slightly different product. But I feel that the way they extract value from it, even being open source, is reputational gains, like I was talking in the beginning. If Dilligence fuzzing, and we've talked about this, and I said at DEF CON that we were going to open source Harvey as soon as Creep got out. Now, this isn't an easy process, because now we're within ConsenSys, large corporation. It needs to go through the board and so on and so forth, right? It's not an easy decision. It's not going to happen overnight. But if Dilligence fuzzing doesn't get to the results that we want, we might consider open sourcing it, because, like, to be fair, there's a lot of value to, we would just go the Red Hat model, if you will. There's a lot of value in having specialized infrastructure that runs this in a smoother manner, like a one-click kind of thing, right? As opposed to like having people set up the tools themselves. So maybe we'd still make money, you know?
Mm-hmm. Yeah, that's the biggest downfall, I think, of all the tooling is it's not user friendly. For example, like Satora, you have to, learn their language to, specify, to even like their specification language to even use it, right? And that's like a massive just like time consumption, and all these developers were building their startups, they don't want to spend time learning some language that they're going to use for like, and then obviously like the bigger people, like the bigger companies, they want it because they can just like pay for someone to do it for them. But the majority of people don't want to spend that money on just hiring someone to write it for them, and second of all spending the time, because it's an opportunity cost at that point of, okay, we're still trying to get our MVP out, but we also need like constant auditing. And so you have to change, or we have to write the specification multiple times and we change everything. It's just, it's not really streamlined at all. And I think that goes with kind of every other tool. There's a lot of setup involved, and it's very complex. And then it's really just like a time trade-off, and people aren't really willing to put the effort in. Well, that's from my experience as well. Like, I don't want to set up anything, because if I can't just like type in a command, hook it up to something, like put in an address, hook it up to something, then I don't really want to use it. I don't want to spend the time learning how to push it in. And if it was really good, people would be like, advertising, oh, use this, and I don't see that, so I don't want to use anything. And even in my mind, like, if something is really good, why would they open source it? Because there's no competition as well, right? And so it's like a free market if you think about it. But it's quite interesting that you guys are thinking of open sourcing Harvey, because I remember when I first started my journey in the kind of fuzzing space of smart contracts, Harvey was the kind of go-to, right? And they use like quite interesting techniques. I think it's been a while since I read the paper, but there's like this kind of gas tracking, which is, a known bound in this fuzzing, whereas normal fuzzing, there isn't really a known bound apart from the parameters. But for the EVM, you can only go up to like a certain amount of gas, and dictating whatever the gas is, it kind of determines whether what branch you go down, or okay, this is going to be an error. For example, if like your memory just creates like this massive like expansion, oh wait, this probably wasn't the right thing then, so go down a different one. I still didn't really like understand the gas thing, but I knew it was quite unique in its sense. So I'm pretty keen to read this.
Yeah, absolutely. Look, I think hearing you talk about that, I think that's my feud with everything formal verification. And I was on a bunch of fun, really, really fun panels with Molly from Certora. And he keeps throwing shade on Scribble because he says, okay, that's not real formal verification. The Certora proving language can do way more. And we're like, that's not what we're trying to do either. Like what is true formal verification is also like a debate that I don't want to get into. And honestly, calling it the holy grail that people keep calling it is just plain wrong, to be honest. Like, I still remember the days when like runtime verification put the KVM model up so that you could write K specifications for the EVM. And then makers spent like a bunch of money, like a lot of money. I can't remember exactly, but it was like in the orders of like 600,000 USD. And then after, I don't know, like 8-9 months, they discovered that the KVM model had a bug in the way they were modeling for loops. And that meant that almost all of Maker's contracts had for loops in them. And so that none of the verifications were actual verifications. They were verifying absolutely nothing. And what I think people fail to comprehend is that people that build the proving engines are still humans. And people that write the specifications are still humans. So Joran Pony from our team, who leads the product side, so he's responsible for everything related to product. He has been asking a question to people from Certora and runtime verification, people just to do formal verification in general. How many times have you caught the bug that you caught with formal verification, just writing the specification in general? How many times did you realize there was a bug before even running the proving engine? So just by going through the effort of writing the specification, of formally defining the program in another language, his question was like, how many times did you catch the bug? Even did you know there was a bug for sure before even running the engine? And people were like, oh, like 95% of times. And so it's more of the effort of going through the effort of formally thinking about something rather than the actual proving part,
Yeah, I think that's the biggest downfall, right? Because, if you're specifying something, then you've got to know it. You got to know what you're actually looking for. And when you know what you're actually looking for, then there's no point having something do it for you because you've just done it.
Yeah, and so that's what I was like, just finishing on this point. That's what we were trying to do with Scribble, right? So we thought like, we don't need like a new language. We don't want to make it hard. We don't want to make it hard for people. We want to try and come up with like a midway step between just like running unit tests and actually doing a full spec in K. And that's Scribble, right? Like Scribble is still Solidity, but it would be the same thing as writing, Foundry tests or something. But we have actually built in like extremely cool capabilities into Scribble, which is like you can use modifiers like old to reference a variable in the previous block. You have modifiers like sum, and they even allow you to sum through mappings, which would be really hard to write in a vanilla solidity test because there's a bunch of considerations. There's gacha hashes involved and shit like that. And so our hope was that like people would start writing Scribble because it's really easy to write, and they don't need to fully specify their program. They could just write some specifications, some invariants every now and then. And it doesn't have any runtime costs. You only transpile it if you want it. You could transpile it during testing time and stuff like that. Unfortunately, I haven't seen as much usage of Scribble as I'd like. I think it's a really powerful tool, and it's free. And I think we just suck at marketing our own stuff, to be honest. So it might be because of that. It might be because people just don't really need it or want it. But I do think that it might be our lack of marketing ability.
I do think it's, user, like, the users want to use it. Is it going to take up too much of their time, etc.? I think that's the main thing, because people are always, building. They don't really want to do all this extra stuff. They would rather just hire a team because they have, a better output than, this might work, right? But these people have like a known track record. Yeah, I mean, even with you guys, like any manual auditing team, they'll have a track record of reports and history. I think the thing with tools now, it's all the benchmarks are just bullshit, and nobody's like actually proving like advanced bugs, right? Like if they want to get like some simple ones, they'll just use like a public
static analyzer or something.
Oh no, like even just like a public bug bounty thing, they get like an audit, right? That just kind of makes sense. You have everybody go for the low-hanging fruit, then you get an audit, and then you're kind of set after that. You don't really need to do anything else as like a standard. But if some tool came out, you don't want to be like, okay, let's just try this. You want to know what it actually produces with some actual examples. So if I were to, release a tool like this, which, I'm planning to do, then my marketing strategy, my go-to strategy to convince someone to use it would be, okay, here are things we've actually done. Here's what we actually found. Or even like an audit report. Just compare like a manual audit report with what the tool does. Do they find the same things, or does the tool even find more things? And then at that point, someone will obviously go, I want to use the tool instead of this team. So I think that's kind of the main thing. And especially with the user, what's it called? Like how easy it is for the user to basically use it, really, is another main thing. If you think about it, and from their perspective, they're just going to hire an auditing team. They do it all for them. There's nothing they really do apart from pay them and, tell them, maybe, okay, this is meant to do this, that's meant to do that every once in a while. With these formal verification things, fuzzers and whatnot, I mean, they're providing inputs of some sorts, and it's just kind of, painful and I guess also very expensive. So that's kind of my point of view on like the whole kind of tooling landscape. I think it's very bad at the moment, hence why I'm doing it.
Let me pick up on something you said and like ask you a question, because that also came up in the panel, and I think that I align with your vision, but I want to understand it. I want you to actually explain it to whoever's hearing. How do you feel about, so you said you'd basically go to a security contest and catch all the low-hanging fruit and then go to the auditors, right? And you might want a tool to replace that first part, because if it's easier or it's cheaper, then it'll pick up on itself, right? No marketing needed. So you do think that people should go to Code before they go to the auditors?
Yeah, I think the auditing team, in my mind, it's a group of auditors, right? And they're looking for really game theory bugs or, critical vulnerabilities. That's kind of what you're hiring for. If you're hiring for low-hanging fruit, that's just a waste of money, right? So, and that's what like these public contests are really for. Sure, you have like the anomaly of someone finding, a high critical. I mean, the chances are it's like 100% true that someone's going to find the low-hanging fruit and kind of, just prepare it for like the next stage. But my whole grand vision is someone can replace the auditing team which I'm trying to do, right? But all the current like bots are really just trying to replace like the public contest kind of thing. In my vision, I think it is possible to, find the game theory bugs in an automated way. It's just like incredibly difficult, but I think that's the challenge, the fun little challenge. But yeah, I think for any auditing, any protocol, you should always write your test with invariance first, then go into a public contest, and then go to an actual team when you think you're at the deployment kind of stage of, okay, we haven't got any lows, mediums. Let's go see if we have any criticals of, external protocols interacting with our protocol, or our one interacting with these external ones. What are the kind of contexts that can happen during its lifetime of, a couple of years, couple of months? What are these states, and how can they be manipulated in such a way where someone can take what they want, right?
Yeah. I'm asking this because like during the panel the other day, during the Cybersecurity Summit, like Jack from Sherlock, he like was a bit caustic and said that like Sherlock was the final exam and everything else was just quizzes. He literally said this, and I don't understand how someone can think that way. Right. I know that Sherlock does have some managed services. It's not only code contests, and they do get like one or two people to join in and like do an actual audit or like an actual security review. I entirely disagree with the vision that these two need to happen at the same time. I just do not understand how people think like that, and hence the question. But yeah, I do fully agree with everything you just said.
I mean, like, you could definitely do it all in one, but I mean, if you're using the same people for it as well, it's kind of, and they're looking over, like, if their mind is focused on the small lows and mediums, then sure, then going into like a critical kind of mindset game theory, it's like divided attention, in my opinion. So that's why I think like having an audit team specifically focused for, criticals game theory is essential. You're not having like this overlap / undivided attention kind of, making you shift in and out of this mindset. It's really not optimal, in my opinion. Yeah, that's how I think it makes sense logically, right? Like the lows and mediums don't necessarily matter, but they may help the protocol in some ways.
Yeah, absolutely.
Understanding, but I do agree in the sense with what he said was like criticals are the main thing, because auditing, in my opinion, right, you're just looking, can I steal funds? Can I brick the system? But obviously teams want to like help the protocol standards and, code quality, which, makes sense, but it depends what you're really paying for it at the end of the day, or what your kind of outcome is. But yeah, I guess that's kind of my take on that. I did want to ask, since you are an auditor, right, I want to know how you find the game theory bugs, the critical vulnerabilities, the ones that steal the money.
So through Cree, through our like initial push, because we just launched the community, we actually have Yor and Honig actually compiled the answers to that question from like a number of people that are joining Cree as well. I haven't been auditing for a couple of years, but I still look at code more in a bug bounty fashion than an audit fashion, which are admittedly different, because bug bounties is like finding one hole in a ship hull, and auditing is like finding all the holes and just like fixing them. The workflow is admittedly different, but lately I go the other way around. So whenever instead of just like looking for all the flaws and reading code top to bottom, if you will, I just search for like whenever there's a money outflow, like dot transfer, dot call, or some shit like that, and work my way backwards with stuff like with visualization tools. The same thing for DOS vulnerabilities. I honestly like the only tool that I've used lately is SamGrep, nothing else. It's just like SamGrep detectors, which was also made possible by Jorn because he made the three-seater parser grammar for Solidity, and actually asked the SamGrep people to support Solidity, and they did. Even though it's not in the last level of support, it's already cool. And that's the only thing that I've been using lately.
Yeah, it makes sense. Yeah, I think it's a common kind of thing I've heard in like the top tier auditors that always find criticals is you always look for the functions that handle money, whether it's withdraw or deposit, and kind of work your way backwards on how do I enter this? How do I influence it? Can anything influence it? Can anything enter it in any way?
Yeah, so might not be just .call.transfer, right? Like anything related to tokens or like allowances or anything. That type of function, which is easy to look for, right? Like with SemGrep is extremely easy to just like write semi-advanced or like highly sensitive. And Joran also has a presentation that he did through Creed on how to actually use your time the best. And I'm definitely not as methodic as he is, because he only works in like 90-minute windows, takes like 30 minutes to rest after that. He's like very, very methodic, Huberman style type of things, like is like his cycles are super aligned. But one of the things that he talks about, and that I even talked about it because I repurposed his presentation for another workshop, is that you just build, like if you are working in this like these bug bounty kind like situations, and most of the time I'm not talking about true bug bounties, but like just if I need to use some code, I'll just at least give it a quick pass, right? Not necessarily, and I don't go necessarily after Immunify bounties, but just like any code. It's to build like extremely sensitive first pass tools, right? And so the SemGrep detectors should be like give you a lot of false positives, because that's what you want. If you have little time to spend on something, you just want something that is overly sensitive so that you can then parse through the results quickly, skim through them. But you want something that is, you don't want false negatives, you want false positives, because then you'll leave some of them to later, but you have a list of things to go after. And I think that's a really good tip.
Yeah, I think false positives over false negatives. Like false negatives isn't helpful at all, but false negatives kind of narrows down what you should look at.
Yeah, for some tools, like I think that like if you have an actual product that you sell as a SaaS, and like like if it's a transaction simulation, for example, and I know that like for example there's a team working on that, like Skylock, Dixon and Robert, and I know that their tool is cool, and Ivan Angel, and they have an obligation to not have false negatives, because their idea was to plug their transaction simulation tool to pausing mechanisms or to possibly front run hacks. So in that scenario, you really don't want to fuck with with LPs or stuff like that, like you want to keep your false negative rate to an extreme low. And there are places for everything, but like if you are doing things manually and if you're looking at code and if you have little time, if you just want to do like some sort of like quick skim, I think that's a really, really, really good way to do it.
I also wanted to touch on this as well, based on like the automation. Why don't you think tools right now are actually finding complex vulnerabilities? For example, multi-function call, like 40 function call, something like that. Why don't you think tools are able to discover these kind of things?
So I can talk to you about Harvey. So first is that clever state space exploration is hard, right? And Harvey does that well. But if we're talking 40 transactions deep, man, we're talking about like weeks of fuzzing, if at all possible, to be honest. If you don't have like very, very, very tight constraints, maybe written in Scribble, to just guide it through the first, say, 4 or 5 transactions, it becomes actually impossible, I'd say. Like, it's just an insane amount of computation power. But it's not only that. It's not only about computation power. I think that it's about the just utter lack of specification that we see. So I was saying that even if you have the specification, the computation power might be hard, but people don't have specifications. In addition to that, I think that like having the tooling is not there yet to easily run, for example, these fuzzing sessions on a super updated forked state of the chain, right? Let's say your DeFi protocol touches a million other DeFi protocols, right? You use Uniswap v2, you use Uniswap v3. It's like you can fork the state of these, but many times, say with like economic risk, what you really need to fuzz is the state of these dependencies, right? In order to get to an exploitable state on your protocol. And this explodes state space by a millionfold, right? Now we're talking like millions of years of computation to get to something interesting. Now we're talking about like Uniswap v2. You're having to devise constraints for the way you want to fuzz Uniswap, which is like an even bigger task because you don't know it as well as you do know your protocol. And so I think that at the end of the day, and I'm a huge fan of agent-based simulations, by the way. And that's another thing, that it's still super manual. You know, there's no easy way. There's no, and I know there are some people doing this, just building products around agent-based simulations, but there's no easy way to create a template of agents that do things in DeFi, or, you know, like it's all very manual. At the very end of the day, I think it boils down to lack of specifications, hard to simulate the state of the chain other than your protocol, and just raw computation power.
Mm-hmm. Yeah, I agree. I think, the thing with fuzzing is the hardest thing is making it, smart. And I think that's really the core problem of, okay, how do you make it smart? How can you make a feedback loop that really directs it in such a way that it's not wasting computational power? For example, this is a really simple example, but using bound analysis, like parameter, right? It tells you the bounds of, to bypass a required statement. Let's say your input has to be greater than 100, less than 1,000. Okay, great. Now you don't have to, fuzz the entire type, which can be insanely redundant. Now you have narrowed this window. And I think the same is true for any type of fuzzing, right? Like whether it's function sequencing, parameter sequencing, or even just, parameter provision. And obviously you can have different combinations, especially if it's like, if you're taking in structs, and it becomes even more complex. But then you're always looking for these constraints, and that's how you really do it. And the whole kind of fuzzing research field is different techniques to make it smart and to remove these time complexity issues, which, I don't know, people are making like nice strides in, but it's nothing major, I think, right now. And nothing to the point where, a tool is able to find a multifunction complex exploit, like Pickle Finance, for example, where it's generating, contracts to interact with an arbitrary address input, and then different sequences of functions after that interaction. And these custom contracts have like 7 functions in them as well. So it's a whole, super, super hard task. But I mean, whoever gets that, they've kind of like conquered the space, I think. Or even like done it to a degree is just a tremendous effort, right?
Yeah. Look, like Harvey is an intelligent fuzzer. Like Harvey is aware of all of that, right? And it reaches the conditional jumps like extremely fast. It converges really fast. But even still, even like solving, well, not solving, because this is not really solving. There's nothing to solve, but even optimizing this to the fullest, like assuming that the tool is extremely efficient, the interest, like just having something to write interesting states that you want to explore. So setting the initial state, right? Maybe you could use Scribble. Maybe you could write your constraints some other way. But there's no easy way to do it. That's what I was talking about as well. Like the things that support the tooling are not really there yet, I think.
Yeah, I agree. Maybe one day there'll be some fully automated version, but I think for the foreseeable future, it's all hybrid.
One thing that I saw the EDFuzz team talk about is how you could like just use LLMs for the creation of specifications. Basically, if like translation of natural languages to a specification language, which it could be good at. And I've talked extensively with Jorn about it, but Jorn doesn't think it's there at all. And we already have Scribble, like we have enough Scribble examples that GitHub's Copilot actually writes scribbles for you if you just write the comment, the beginning of the comment. But it's just not there yet. Like it just doesn't work yet, because otherwise that would be dope, right? If I can just like go, like when I'm writing my tests or like when I'm testing my system and I just go and write, hey, I want you to create a specification for a user A sending 100 tokens to user B, and then user B sending a transaction to function X, and I want you to fuzz from there. If this was capable, like if LLMs are capable of doing this today successfully with little to no transformation from their output, I think this would actually solve like all of the things that I'm complaining about. I just don't think we're there yet. Like, at least I've tried multiple things, even vector embeddings and like training the LLM on a bunch of Solidity contracts and scribbled contracts. And it still didn't work out as expected. So I don't know if we're going to get there. I don't know if it's a limitation. I also don't know enough about the workings of LLMs to know if this is like a computation power limitation, whereas if I had like a lot of embeddings, like it would work better. I don't know if it's just a limitation of just like LLMs themselves. I don't think so. I think we might be able to get there, but we're not there right now.
Yeah, I definitely think the future of AI is going to be definitely a major factor in the world of smart contract fuzzing. If you're able to, create invariants of business logic automatically, then that's the holy grail at that point. That's what you test against. But for now, certainly manual invariants. And I don't know, I wouldn't bank on waiting for AI right now. A long way to go, so better get good at that invariant testing, my friend. But definitely keep in mind that it's going to happen in the future. When it does, obviously everybody's going to convert over to it if it works as intended. But otherwise, thank you so much for coming on, Goncalo.
Thank you for having me.
Really appreciate you using your time here. Don't want to spend any more of it, but I really appreciate the chats we've had, especially since it's our first time chatting as well.
Absolutely. I love the conversation, DeGatchi. Thank you so much. Like I think it was really, really fun. I loved it.
Great. And I hope the audience enjoyed it as well. I'm sure they did. And if anybody wants to come on or wants to suggest someone to come on, just DM me at Scraping Bits on Twitter and I'll take a look. Otherwise, thanks for listening and hopefully see you on another episode.